This quantum number is also called secondary quantum number. This is also called a subsidiary. This is also called a lesser quantum number. These are the names of this. And this quantum number was given to explain the fine lines of the spectrum. This was used to explain the fine lines of the spectrum. You know, and spectrum of elements not contains not only the main lines but there are fine lines also. To explain these fine lines, it was such that electrons present in the main shell that is crystal shell in case of multi-electron atoms, do not have same energy. Because they move in different paths and have different angular momentum. As the number of jumps increase, and so the number of lines. You know, electrons present in this main structure, in case of multi-electron atoms, do not have the same energy. So because they move different paths, they have different angular momentum. So as the number of jumps increase, so the number of lines increase. So this quantum number, thus we can say that within the principal shell there are number of subshells. Thus within the principal shell, within the main shell, within the main shell's main energy levels, there are sub-levels or subshells. So the asymptotic quantum number, it gives information regarding angular momentum of the subshells, relative energy of subshells, number of subshells, so azimuthal quantum number gives information regarding angular momentum of subshells, relative energy of subshells, and the number and shape of the subshells. Now, mathematically, azimuthal quantum number is given by mu, or if you write math is equal to h by 2 pi under root of L and L plus 1. Mathematically, it is given mu is equal to h by 2 pi under root of L and L plus 1. It is denoted by, that is, azimuthal quantum number is denoted by L, and values of L depend on principal quantum number, that is n. For example, for a given value of L, for a given value of n, L has value 0 to n minus 1. For example, if n is equal to 1, L can have value that is 0 only, 1 value. If n is equal to 2, L can have value 0 and 1, because it is 0 to n minus 1. Here, if n is equal to 2, L is equal to 0 and to 2 minus 1, that is 0 and 1. If n is equal to 3, L can have value 0, 1 and 2. If n is equal to 4, L is equal to 0, 1, 2 and 3. That is, the total values of L, जितने values की total values हैं, that are equal to the number of n. Total values of L, as azimuthal quantum number, is equal to n. n के values कितने हैं? Total values of L is equal to n. यहाँ पर L के दो values हैं, 0 and 1, and n here is number is 2. So there are two for n is equal to 2. There are two values. When n का value 3 है, there are three values 0, 1 and 2. When n is equal to 4, यहाँ पर four values होंगे L के 0, 1, 2 and 3. And 0, 1, 2 these are given the names. 0 stands for S, 1 P, 2 D, F, and 3 is equal to F. These are derived from the words S means short, this means principal, P, D means diffused, F means fundamental. So, when n has one value, that is station, there is only one subshell, that is S, and with n equal to 2, this is L shell. There are two values, L has two values, there are two subshells, S0 is S subshell, one is P subshell, and in L3, L has three values, there are three subshells, this is S subshell, this is P subshell, and this is D subshell. And when L is equal to 4, there are four values, there is S subshell, P, D, and F, and so on. So, azimuthal quantum number tells us number of subshells, it tells us the energy of the subshells, because in case of energy, S has lower energy than P, P has lower energy than D, P has lower energy than F. It tells us this is the energy, it tells the energy of the subshells. So this was the azimuthal quantum number. It gives information regarding the presence of fine lines in the spectrum. It gives information regarding the energy of the subshells, angular momentum of the subshells. It gives the shape of the subshells. इसके बाद दूसरा क्वांटम नंबर है, that is called the मैग्नेटिक क्वांटम नंबर. This quantum number was used, it was given to explain the Zeeman effect. This was used to explain the Zeeman effect, that is the splitting of line spectrum and to the fine lines under the influence of the magnetic field. Splitting of the line spectrum in the magnetic field is known as the Zeeman effect. Now, you know, electron, due to its angular momentum, due to this orbital motion, around the nucleus produces electric field. It has its electric field due to its orbital motion around the nucleus. It has its electric field, and electric field in general generates the magnetic field. It produces a magnetic field and it interacts with external magnetic field, which interacts with the external magnetic field. So, under the influence of the external magnetic field, external magnetic field, an electron orients itself. Electrons orient themselves in preferred regions. Each preferred orientation gives represents the orbital. Each preferred orientation represents the orbital. So magnetic quantum number tells you information regarding, it gives information about the orbitals present in the main subshell. This quantum number is designated by M. It is designated by M, and however, if L is equal to 1, if L equals 0, M can have value for any value of L, for any value of L, for any value of L. M can have value minus L through 0 to plus L. Total value will be 2L plus 1. L is equal to 0, M can have value 0. If L is equal to 1, M can have value minus 1, 0, plus 1. If L is equal to 2, M can have values minus 2, minus 1, 0, plus 1, plus 2. If L is equal to 3, M can have minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. That is minus L through 0 plus 1. That is, if L is equal to L through 0, this is the S subshell, so this is the S orbital. And This is f subshell is 1, it's the p subshell, this is the p orbital. And d subshell, this is the d subshell, this is the d orbital. And this is the f orbital. So in p subshell there are three p orbitals, px, py and pz. There are three p orbitals. 3 p orbitals. There are five d orbitals. And there are 7 m orbitals. These p orbitals, they have same energy. They are called degenerate orbitals. They are called degenerate orbitals, but this degeneracy is broken under the influence of external magnetic field. So this is px, py, and they have these are the d orbital, dxy, dyz, dzx, dx square, y square, dz square. So these are the orbitals. Magnetic quantum number gives the information regarding the orbitals and the type of orbital. These are the magnetic quantum number and the SW quantum.